everyone, I am Evelin and my student ID is 21.
I'm Angeline and my student ID is 6.
And in this video, we will explain about 1 and 2 sample tests of hypothesis, which is important in business decision making.
Why is it important?
It is important because hypothesis testing will allow business to make decisions based on a sample data rather than intuition. And the businesses can also make strategies for their future. And now we will present 5 different cases from Chat-PDF and explain the solution.
Starting from the first case, it is about one sample task where population standard deviation is known. The case study is about a horticulturist that believes that a new fertilizer called GrowMax will increase the average height of tomato plants. Historically, the average height of tomato plants without any fertilizer is known to be 30 inches, with a population standard deviation of 5 inches. The horticulturist decides to conduct a one-sample hypothesis to determine if the new fertilizer has a significant effect on the plant height. The objective is to test whether the average height of tomato plants treated with GrowMax is greater than 30 inches. Here we can know that it is a one tail because the keyword here is greater than. This is the solution that we got when calculated manually. The first step is to determine the hypothesis. The HO is mu less than equal to 30 and H1 is mu greater than 30. And for step 2, the level of significance that we got from the question is 0.05. Next, since the population standard deviation is known, we will use the C-test for the hypothesis testing. Then, if the computed value of Z is greater than 1.645, we will reject the null hypothesis. And this is the curve. Greater than 1.645 will be the region of rejection. Then for step 5, there is the Z formula, and the answer that we got is 2.53. The decision will be, because 2.53 is greater than 1.645 that we got from the table, we decide to reject the null hypothesis. Then step 6, in conclusion, there is sufficient evidence as the 0.05 significance level to conclude that the average height of tomato plants treated with GrowMax is greater than 30 inches. So the horticulturist should use the GrowMax to grow the tomato plants so that the result will be better. Next, we have the code. And the answer from both manually and code is the same. Next is the second case, which is one sample task where population standard deviation is unknown. This is the case study. It is about evaluating the average daily screen time of college students. A researcher is interested in understanding the average daily screen time of college students as there are concerns about excessive screen time affecting their health and academic performance. Previous studies suggest that the average daily screen time for college students is around 6 hours. However, the researcher believes that this average may have changed due to the increased use of online learning platforms during recent semesters. The population standard deviation is unknown, so the researcher will use a sample to conduct the hypothesis test. Here, the objective is to test whether the average daily screen time of college students has changed from the historical average of 6 hours. Here we can note that this is a two-tail because the keyword here is has changed. This is the one that we calculated manually. As for step 1, the H0 is mu equals to 6 and H1 is mu not equals to 6. And step 2, the level of significance is 0.05. Next, since the population standard deviation is unknown, here we will use the t-test for the hypothesis testing. And the next step, we will reject the null hypothesis if the computed value of t is greater than 2.045 and less than minus 2.045. The 2.045 we got from the table. And this is the graph with the region of rejection. And next for the step 5, here we have the t formula, and the answer that we got is 2.92. The decision that we will make is because the 2.92 is greater than 2.045, we will reject the null hypothesis. Next for the conclusion, there is sufficient evidence at the 0.05 significance level to conclude that the average daily screen time of college students is different from 6 hours. So it is okay for the college students to continue learning using online learning platforms. Next, we have the code, and the answer that we got from both manually and code is the same. Next, for the case 3, it is about two sample tests where independent samples and population standard deviation is known. The case study is about comparing the effectiveness of the two study methods on exam scores. And the background, a university professor is interested in determining whether a new study method, active learning, is more effective than the traditional study method, which is lecture-based learning, in improving students' exam scores. The professor believes that using the active learning method will achieve higher exam scores compared to those using the traditional method. The population standard deviation for both methods are known from previous studies. For the active learning group, the standard deviation is 10, and for the lecture-based learning group is 12. And here, the objective is to test whether the average exam score of students using the active learning method is greater than that of students using the lecture-based learning method. This is for the solution that we calculated manually. As for step 1, HO, mu active learning less than equal to mu lecture-based learning, and H1 is mu active learning greater than mu lecture-based learning. It is less than equal to and greater because from the question we can see that the keyword is greater than. Next, for the step 2 is the level of significance, which is 0.05. And since the population standard deviation is known here, we will use the C-test for the hypothesis testing. And for step 4, we will reject the HO if the C is greater than 1.645. And as we can see here, the region of rejection. And next, for the step 5, we will use the C formula, and the answer that we got is 2.46. So we will reject the HO because C is more than 1.645, and the 1.645 we got from the table. And in conclusion, there is sufficient evidence as the 0.05 significance level to conclude that the average exam score of students using the active learning method is greater than that using the traditional method, which is the lecture-based learning method. So the professor should use the active learning method as it is more effective towards the student scores. Next, we have the code here. And both answers that we got from manually and code is the same.
Okay, so for the next case, it is about two sample tests with independent samples and population standard deviation is unknown. Okay, so this is the case study which is about shampoo effectiveness. And the scenario is a researcher is interested in comparing the effectiveness of two different brands of shampoo, which is the brand A and brand B, in terms of the average amount of hair loss experienced by the user after 1 month of use. And the researcher collects the data from 2 independent samples of users who use each brand, with the level of significance, which is 0.05, and this is the sample data for the brand A and brand B. From this case study, we can know what hypothesis we should use. By this keyword, which is comparing the effectiveness, we know that this case is two-tailed. Okay, so this is the solution that we write manually. The first step is to determine the null hypothesis and the alternative hypothesis, which is mu brand A equals to mu brand B and mu brand A not equal to mu brand B. And for the next step, we will write the level of significance that we got from the question, which is 0.05. And next, for the third step, we will use the pool t-test because the population standard deviations are not known and the samples are independent. Next, the fourth step, we will reject H0 if absolute T is larger than T alpha or T table. And next, we will calculate the degree of freedom, which is we got the degree of freedom is 22, and from this degree of freedom we can know the T table, which is 2.074. And after we know the T table, we will draw the curve, and the curve is like this with the region of rejection larger than 2.074 and less than minus 2.074. As for the next step, which is step 5, we will calculate the mean and standard deviation of each brand. And here is the sample that we got from the question. We calculate the mean of brand A, which is 6.667, and the mean of brand B, which is 4. Next, we calculate the standard deviation, and we got the standard deviation, which is 1.3939. Next, we will put the mean and standard deviation into the t calculation with this t formula, and we got the result, which is 5.533. And the next step is the step 6. We got the conclusion, which is the null hypothesis is rejected. There is a significant difference in the mean hair loss between 2 brands of shampoo. So, from our calculation, the researchers should use the brand B shampoo because it is more effective and the hair loss will be decreased after a month of use. Next, this is the solution that we calculate using Python. Here is the code, and this is the result that we got from Python. It is the same from the result we got from calculating it manually. Okay, so this is the last case, which is a 2-sample test with dependent samples. And this is the study case that we got. The background is a popular video game company has developed a new training program designed to enhance the performance of players in their flagship games, which is Battle Arena. The company believes that this program will help players improve their scores significantly. To evaluate the effectiveness of the training program, the company decides to conduct a study with a group of players. And the participants is 8 players who are regular participants in online tournaments and are selected to participate in the study. Each player will undergo the training program, and the performance will be measured before and after the training. And here we will use the level of significance, which is 0.05, and this is the data collection with the performance scores before training and performance scores after training. And from this scenario, we will know that it will use one tail because the keyword is to improve their scores. Okay, so next, this is the solution that we write manually. The first step is to determine the hypothesis which is the null hypothesis and the alternative hypothesis. The null hypothesis is the mu before is greater than equal mu after, and the alternative hypothesis is mu before is less than mu after. And for the next step, which is step 2, the level of significance is 0.05. And for the step 3, we will use t-test because this is a dependent or paired samples. And for the step 4, we will reject null hypothesis if t is less than minus t table. We calculate the degree of freedom first, and we got it with the formula n-1, which is 7. And we got the t is less than minus 1.895 from the C table. And this is the curve that we draw, and this is the region of rejection, which is less than minus 1.895. And the next step is step 5. Here we got the samples of before the training and after the training. Here we calculate the difference, and we got the difference, which is minus 9. And the next one is the standard deviation. We calculated using the difference, and we got the standard deviation is 1.852. And here we will calculate the t value with the t formula, and we got the result, which is minus 13,745. And as for the last step, the conclusion is the null hypothesis is rejected. The player scores improve significantly. So from this, based on this calculation, we know that the training method from this game company is effective. So the company should use this training method for in the future. Okay, so the next one is the code that we is the solution that we got from using Python, and this is the result with the difference, and all of this result is the same with what we calculated manually.
Thank you for listening. Sorry for any inconvenience.
Thank you.